There's a single picture from the James Webb Space Telescope that scientists still can't fully explain. It's a long stare into one tiny patch of dark sky, and it comes back full of little spiral galaxies, hundreds of them. Some of those galaxies spin one way, others turn the opposite way. And you'd expect that to come out like a coin flip, roughly half and half. But when a scientist actually sat down and counted, it wasn't close. Most of them were turning the same direction. Galaxies aren't supposed to do that. So the question is simple: why? That's a real study, published in a peer-reviewed astronomy journal in early 2025, and the answer the headlines reached for was about the biggest one there is, that the whole universe is turning, that we're all sitting inside a black hole. The finding really is strange, and it's worth your time. It's also one of the most oversold science stories of the year. I'm going to try to keep both of those in view the whole way through, because the honest version of this story needs both. Here's what I'm going to show you: what the telescope actually looked at, and what it even means to say a galaxy spins one way or the other. The count itself, the thing that started all of this. And then the part the headlines mostly skipped, which is that there are two explanations for what was found. The black hole is only one of them, and the man who found it doesn't think it's the more likely one. There's one line in his paper I keep coming back to. He wrote that you wouldn't need any of the math to see this. You could see it, he said, with your own eyes. File that away, because that plain little claim ends up doing two completely opposite jobs in this story before we're through. To understand why a lopsided count of galaxies would send anyone reaching for black holes, you have to know what the telescope was actually doing. The picture at the heart of this isn't a snapshot. It comes from a project called the James Webb Advanced Deep Extragalactic Survey, which is a mouthful, so people just call it JADES. The idea behind it is almost stubborn in how simple it is. You point the most powerful telescope ever built at one small, unremarkable patch of sky, a piece so tiny you could hide it behind a grain of sand held at arm's length, and you just stare, not for a second, but for days of gathered starlight, stacked into a single frame. And what comes back is staggering. Every faint smudge in it is a whole galaxy, an island of 100 billion stars, and there are hundreds of them crowded into that one little square. Webb is built for exactly this. It works in infrared light, the kind our eyes can't catch, which lets it pick up the oldest and faintest galaxies of all, the ones whose light has been stretched thin and dimmed by billions of years of travel. Older telescopes simply couldn't reach them. Here's the part that bends your head a little. Because light needs time to cross space, staring deep into the distance is the same thing as staring back into the past. The faint galaxies in that long exposure aren't how they look today. They're how they looked billions of years ago, some of them from when the universe itself was still young, only a fraction of its current age. That still stops me every time I really think about it. So JADES isn't really a snapshot of the sky today. It's a slow photograph of the early cosmos, developed one particle of light at a time. So what does it even mean to say one of those galaxies spins a certain way? A spiral galaxy has arms, long curving lanes of stars and gas that wind out from the center like the arms of a pinwheel. From where we sit, those arms appear to turn in a direction. Some coil clockwise, others counterclockwise. It's a simple thing really, just which way the pinwheel happens to be facing you. And for a very long time, nobody thought it meant anything at all. It was treated as a coin flip, a bit of cosmic trivia with no pattern behind it, which is exactly why what came next landed so hard. That assumption actually has a name. Cosmologists call it the cosmological principle, and it's one of the quiet foundations sitting under almost everything we think we know. In plain terms, it says the universe has no special place and no favored direction. Look one way, look the other, and on a large enough scale you should see the same kind of thing. No center, no edge, no particular way the whole thing prefers to turn. And I'll be honest with you, the first time that idea really landed for me, it struck me as almost too tidy, the kind of clean rule the universe seems to enjoy breaking the moment you get comfortable with it. Follow that principle down to our pinwheel galaxies, and it makes a flat prediction. If direction genuinely doesn't matter, then across a big enough pile of galaxies, the ones winding one way and the ones winding the other should come out roughly even. Not exactly 50-50 on any given night, the same way 100 coin flips are rarely exactly 50 heads. But close to it, and closer the more you count. A strong, stubborn lean toward one side isn't supposed to be possible, because a lean like that would mean the cosmos has a way it prefers to turn after all, and that is the one thing the standard picture doesn't allow. So that's the wall this whole story runs straight into. Even odds, no favored direction, one of the load-bearing beliefs of modern cosmology. Hold it in mind, because everything from here is about a crack running through it. The scientist who went looking is named Lior Shamir. He's an associate professor at Kansas State University. And here's a detail I think matters more than it first appears. He isn't an astronomer by training, he's a computer scientist. His whole field is teaching machines to sift through enormous piles of images and pull out the patterns, and for years he's aimed that skill at galaxies. So when the JADES pictures came out, he did the thing he does. He went through them and, one at a time, sorted the galaxies by which way they turn. The method is almost boringly plain, and that's the point. He took the galaxies in that deep field that were clear enough to actually read, sharp enough that you could tell which way the arms wound. That left 263 of them, not millions, just a few hundred, each one looked at directly. Then he split them into two piles, one pile turning with our galaxy, one turning against it. That's the entire experiment. There's no exotic instrument here, no billion-dollar detector buried under a mountain. It's counting, the kind of thing a careful person could sit down and check by hand, and that plainness is going to matter a great deal in a minute. A count this simple is also the easiest place in the world for a mistake to hide, because a slip in how you sort a few hundred fuzzy smudges can slide right past everyone. But hold that thought, because first you need to see what the count actually said. Of those 263 galaxies, 158 were turning one way, 105 were turning the other. Say those two numbers out loud and let them settle for a second. That's not a hair's width gap you'd need a supercomputer to tease out. It's roughly 60 to 40, half again as many galaxies leaning one way as the other, when the rulebook said it should have been an even fight. And this is the part that really gets to me. That line I filed away earlier, the one about not needing the math, this is it. Shamir wrote that the imbalance was big enough to spot with your own eyes, no statistics required, and he's right. You can pull up that field of galaxies and, without running a single calculation, watch them lean. The early universe, in this one deep photograph, doesn't look balanced. It looks tipped. Now feel how big a problem that is. The cosmological principle said the universe has no favored direction. This one clearly does, sitting right there in the picture, plain enough that you can see it. Something has to give. Either one of the deepest assumptions in all of cosmology is wrong, or something about this measurement is quietly fooling us. And that fork is the entire story, because there really are only two ways off it. The first road is the one that made the headlines, and I'll give it to you straight, since it's a real idea and it deserves a fair hearing. Start with a simple question. What could make galaxies all across the early universe favor the same spin? The cleanest answer is that they all got the same push. Picture the whole young universe as very slowly turning, like one enormous, invisible whirlpool. Every cloud of gas that later collapsed into a galaxy would have been caught in that same rotation and handed a slight nudge to spin along with it. So in that story, a galaxy is leaning the way it does because the entire universe it formed inside was turning, and it simply inherited that direction. And I want to be clear about how radical that is. A universe that turns has an axis, a real preferred direction baked into it from the very first moment. The ordinary Big Bang has no room for that at all. It gives the universe no reason to spin in the first place. So if the universe really is turning, that just raises a harder question. Where did the spin come from? And this is the step that leads to the black hole. Think about how one of them actually forms. A giant star runs out of fuel and collapses, and as it shrinks, it spins faster and faster, the way a spinning skater speeds up by pulling their arms in. Almost every black hole out there is turning, and turning hard. Now here's the theory that ties it together. A physicist named Nikodem Poplawski at the University of New Haven works on a version of Einstein's gravity with an extra twist built into it. In his math, matter falling into a black hole doesn't crush down to a single point and vanish. It bounces, and that bounce blooms into a whole new universe, sealed inside the black hole forever. The idea goes back to physicists in the 1970s, but he's the one who gave it a real mechanism. And that's what makes it click. A universe born inside a spinning black hole would come out already turning, because it inherited the spin of the parent it formed inside. So there's your chain, all the way down. Galaxies leaning one way could mean the whole universe is turning, and a turning universe is exactly what you'd expect if it was born inside a spinning black hole. That original spin would be a kind of birthmark left on everything inside it, right down to which way the galaxies turn. That's the sentence that ran around the world. James Webb finds the first real sign we're living inside a black hole. But there's a second road off that fork, and it's a lot quieter, and it comes from the very same man who found the imbalance. Shamir's other explanation is that maybe the universe isn't turning at all. Maybe we are. Think about how a siren changes as an ambulance goes past. Coming toward you, the pitch sounds higher, and as it moves away, the pitch drops. That's the Doppler effect, and light does the same thing. A galaxy moving toward us looks a touch brighter, and one moving away looks a touch dimmer. Now, our own Milky Way is turning, and it's carrying us along with it at real speed. So galaxies that happen to be rotating against our motion get a small brightness boost, and the ones rotating along with us get dimmed down a little. And when you're hunting for the faintest smudges at the very edge of what a telescope can see, a small brightness boost is the difference between a galaxy you manage to count and one you miss entirely. You'd end up overcounting the ones that lean against us. And that tilt wouldn't be out in the universe at all. It would be in us, in our own motion, the one thing we forgot to subtract back out of the picture. If that's the answer, it can sound like a letdown after black holes, and I want to push back on that, because it really isn't one. If our own motion is tilting what we measure without our realizing it, then some of our most basic measurements of distance across the universe are off by a bit, and correcting that could reach right into some of the biggest open puzzles in the field. Like why the universe seems to be expanding at two slightly different speeds depending on how you measure it, which is a real, unresolved crisis in cosmology right now. Or why James Webb keeps turning up galaxies that look older than the universe is supposed to allow. A humble bookkeeping error, if that's what this is, would still shake an enormous amount loose. So both roads lead somewhere strange. Neither one, on its own, is a black hole confirmed. And now I have to do the thing the headlines skipped, which is tell you honestly how much weight this can actually carry, because it's a good deal less than it sounds. Start with the size of it. 263 galaxies isn't many. Physicists have a bar for a claim like this, a level of certainty they insist on before they'll accept that something real is going on and not just a run of luck. They call it 5 sigma. In plain terms, it means the odds of the result being a fluke have to come out smaller than about 1 in 3.5 million. That's the bar you clear to rewrite a rule of the universe. Shamir's result doesn't come close to it. It lands far below, at a level that says, this is interesting and probably not pure chance, but nowhere near settled. On a few hundred galaxies, that's honestly right where you'd expect an honest result to sit. Then there's the harder problem, and it loops straight back to that line about seeing it with your own eyes. The whole finding rests on a person, or a program a person wrote, looking at a fuzzy smudge and deciding which way it winds. And that's exactly the kind of judgment that can carry a hidden bias without anyone meaning to cheat. Here's the test other researchers have run. Take the same images and flip them, mirror them left to right, so that every clockwise galaxy now reads as counterclockwise. If the lean is real, out there in space, it should flip cleanly along with the picture. But when some teams do this, the gap nearly disappears, which is a strong hint that part of what's being measured isn't the sky at all. It's us, and our tools, and the small ways we tilt toward seeing one thing over another. That naked eye, the very thing that makes the result feel so undeniable, is also the exact spot the error would be hiding. And Shamir isn't the first person to report a lean like this. He's been finding versions of it for years, across one sky survey after another, and other scientists have spent those same years arguing it isn't really there. One well-known reanalysis redid the whole thing and watched the imbalance melt down into noise, consistent with no favored direction at all. And the core of the disagreement is always the same. Is this a real signal coming from the sky, or a byproduct of how the images get sorted? Change the method a little, or hand the same galaxies to a different team, and the lean can grow, shrink, or vanish outright. That kind of wobble is exactly what you'd expect from a bias creeping in, and not at all what you'd expect from a solid feature of the cosmos. In 2024, another team published a paper whose title doesn't leave much room for argument. They called it, No Evidence for Anisotropy in Galaxy Spin Directions. That long middle word just means a preferred direction, and their answer was that they looked and found none. So this isn't a closed case with one stubborn holdout. It's a live, unsettled fight among careful people, and the honest answer is that we don't yet know who's right. So here's the honest version, the one I wish the headlines had led with. We know one thing for sure, that a few hundred galaxies in one deep image really do lean one way. What we can't say yet is the part that actually matters, whether that lean is a fact about the universe or just a quirk of how we measure it. Which makes a spinning cosmos, let alone one sitting inside a black hole, a maybe stacked on top of another maybe. Which brings me back to that headline, because I think it's earned its own honest word. We're living inside a black hole is a terrifying sentence. It's also doing a great deal of work the science underneath it can't support. The idea that every black hole holds a universe is real, and serious people work on it, but it has no observational proof of any kind, and this study is not that proof. Shamir never claimed it was. He offered it as one possibility among others. The certainty got added later, by the people passing the story along. And the thing I keep turning over is that the real result never needed the exaggeration. A visible tilt in the early universe that nobody can yet explain is already strange enough on its own. The thing I keep landing on, though, is that this is just what real science looks like from the inside before the answers come in. It's messy and slow and unfinished. One careful person found something odd, laid out two honest explanations, and refused to pick between them, and a whole field of other careful people are now pushing back and running the numbers again. That back and forth is the process working exactly as it should, refusing to be rushed. Nobody gets to hand us the answer on a schedule. We get an anomaly, and then we get years of patient work to find out which anomalies were real and which were only ever mistakes. And the honest truth about this one is that bigger surveys are already coming, ones that will take in vastly more galaxies than a few hundred, and that flood of data is how a question like this finally gets settled, not with one deep image, but with a mountain of them. And if the lean is truly out there in the sky, it'll survive all of that. The same lopsided count will turn up again in millions of galaxies, sorted by different teams using different methods, and it'll hold steady even when the images are flipped. That's the real test, and it's one no single deep photograph can pass on its own. So here's where I'll leave you, and it's a place you can actually go. That deep field, the one this whole story came out of, is public. You can open the James Webb image of that little dark patch of sky tonight, the same crowd of spiral galaxies Shamir counted, and you can sit and sort them by eye, the way he did. Some turning one way, some the other. Look long enough, and you might even catch the lean yourself, that faint sense that the early universe is tipped in one direction. And then you get to hold the honest, dizzying question that no headline can close for you. Are you looking at the shape of everything there is? Or just at the reflection of our own small motion, staring back at you? Nobody watching this knows for certain, and that uncertainty is the whole point. You're standing right at the edge of what anyone knows, on a question the sky hasn't answered yet. If that's the kind of place you like to stand, the live edge of a real discovery, before the answers are in, and while the argument is still loud, then subscribe, because that's the whole of what I do here. I go looking for the strangest open questions in the sky, and try to tell you honestly what we know, what we only suspect, and where somebody's selling a certainty that hasn't been earned yet. There are more of these out there right now than you'd ever guess, and I'll keep bringing them to you.